Okay, let us discuss problem number 1.145. So this is an easy problem. Now let me first make the diagram and then we'll discuss. And then you have a chain. So this is the vertical axis about which the chain is rotating. So let me make the chain something like this. So this angle given, this angle is theta, and they call this as a this point, this is rotating with angular velocity omega. So angular velocity is given to you omega. Now let me read the questions. This is figure 1.37. So what this question says, a closed chain A of mass m, so mass of the chain is given to you m, is attached to a vertical rotating shaft. So this chain is attached to a vertical rotating shaft by means of a thread. So this is attached by a thread and rotates with a constant angular velocity omega. And this thread is rotating, so this chain is also rotating with angular velocity omega, constant angular velocity omega. The thread forms an angle theta with the vertical. Find the distance between chain and the center of gravity of rotation axis and the tension in the thread. So we have to find what is the tension in the thread. It's one part. And the second part question says find the distance between chain center of gravity and rotation axis. So distance between, so let us say R is the distance, we have to find R. And what is R? This is the distance between CG of chain, center of gravity of chain, and vertical axis. So let us see how we will proceed for this problem. So you think slightly. So let us assume if this is 100% circular, then in that case center of gravity will lie here. But let us say center of gravity is here. So this is the center of gravity. Now what I will do is, so the same problem can be written something like this. So this is my vertical axis and center of gravity is here. Let us say this distance is r. Now to write down the equation of motion of chain, what I will do is, I will apply all the forces on the center of mass. So what are the forces that is acting on the center of mass? You see, there is a force T in this thread. The component of T in the upfield will have T cos theta, and in the downward direction this side we will have towards the center will be T sin theta. So what I will do is, I will apply here itself T cos theta up, and there will be a force mg that will act downward, and one force that will act towards the center, that is T sin theta. So let me write here itself. So T sin theta I can show in a different diagram, or let me show here. So this force is acting towards the center, this is the T sin theta. Are you getting? And this distance is r. Now center of mass or center of gravity is itself moving in a circular orbit of radius r. So CG of this system, this chain, is moving in a circular orbit of radius r. That the distance between chain CG and vertical axis is r. Now things are very easy. We can solve the problem easily. So vertical equation I can write t cos theta is equals to mg. So this is one equation we have. Now I can write another equation in the radial direction. So radial direction force is t sin theta. So force in the radial direction is t sin theta. This should be equals to m omega square r. R is the radius of circle in which center of mass is moving, center of gravity is moving. So if you divide these two, I will have tan theta is equals to omega square r by g. Theta is given to you, so r will be g tan theta by omega square. So this is the radius in which CG of the chain system is moving in the circulating g tan theta by omega square. Question also says find the tension. So if you plug the value of r in the equation 1 or equation 2, you can get tension is omega square m omega square r by sin theta. So m omega square r by sin theta you have. So m into omega square r is given by g sin theta by cos theta, that is tan theta, into omega square, and you will have 1 sin theta here. I am writing tan theta as sin theta by cos theta so that I can cancel this sin theta. So you will have tension is mg omega square, this divided by omega square also gets cancelled out. So this omega square gets cancelled out, so there is no need to write omega square. So mg by cos theta. So this means tension is mg sec theta. So we will have mg sec theta as the tension in the thread. Are you getting? So what this question suggests, this question gives me one idea, that is if I want to write the equation of motion of a rigid body, so this chain is basically a rigid body. So what we can do is, I can apply all the forces as center of mass. So you see what we have done is, for the forces that is acting, one force is t cos theta, another force is mg, another force is t sin theta. So this force is t sin theta that is acting in this direction. So t sin theta is acting in this direction. So I am applying all the forces on the center of mass, and I am writing the equation of motion for the center of mass. Center of mass in this case is moving in a horizontal circle of radius r. So I can write equation of motion, force towards the center is equals to mass into acceleration, that is m omega square r. And the vertical direction I can write equation, that is t cos theta is equals to mg. From there I can solve for omega as well as r as well as t. Let's discuss the next problem. This is a pretty easy problem.